Hello everyone, welcome back to BC Calculus. We're in lesson number 38. We're talking about polar graphs, and in this particular video we're going to talk about polar graphs, what they look like, but more importantly the behavior of the functions as we graph them from 0 to 2 pi. So in the previous video we talked about visually what the graphs look like. So you guys know from the last video that these are all our circles. So the first 6 examples that you see here are circles because it's just a times either sine or cosine of theta, right? And it's all 1 theta and stuff like that. So you guys know from the previous videos that 2 cosine of theta, well, cosine being the x-axis, and then positive 2 means that we're going to go and graph 2 units like that, right? So the diameter is going to be 2. 3 cosine of theta would be 3 on the right-hand side, right? So the diameter is going to be 3 for our circle. And then if it's negative 3, we're going to be to the left. So awesome. We know what the idea of the graphs look like for this. And then for 4, 5, and 6, well, they're all sine, so they're going to be symmetric to the y-axis. 2 sine of theta means that we're going to go up 2. 3 sine of theta means we're going to go up 3. And then negative 3 sine of theta means we're going to go down 3. So that's fantastic. That's great. But that's not calculus. That's just really straightforward pre-calc how to graph the problems. So what we're going to do now is we want to talk about behaviors. What's going on when we look at this from 0 to 2 pi? So we're going to use our calculator to help us out with this. So first thing we're going to do is let's make sure our calculator is set up. So I have it on the screen for us here. First thing you're going to do is you're going to go to mode, and you're going to make sure your calculator is in radian, and then you're going to go down here to function, and you're going to put it in polar. So radian, polar. So for all this unit, we're going to be polar, polar, polar. The next thing you guys are going to do is you're going to go over here to your windows, and you're already defaulted for the first 3. So the 0, the 2 pi, and the 0.13. So we're all good with those right there. So all we're going to do is we're going to change negative 5, positive 5, 1, negative 5, positive 5, and then 1. So again, and you guys can see it right here on your screens that 0 to 2 pi, it's already set for us. The 0.13, leave that alone. And then you're going to go from negative 5 to 5 for x and y. And then the last thing we're going to do before we set these up, and this is most important, guys, is we're going to come over here to where we see the little r, and we're going to change it. We're going to press enter twice, and you're going to see this sign. All right, it's going to look a little bit like a key or a doorknob or something like that. So we're going to now compare 1 and 4. So we're looking for 2 things here. Where does the graph start? Because that's super important. Where does the graph start? And how many times does it repeat itself over the interval from 0 to 2 pi? So let's go ahead and graph, because yeah, it's great that we know what the graph looks like, but we really care more about the other things. So let's go ahead, the other 2 I just mentioned. So we get 2 cosine of theta, and we're going to press enter, and we want to graph it. So let's see what the graph for this looks like. So you see, guys, it started here. Nope, here's our second rotation. All right, and so that's 2 important things here. So let's go and mark our picture. So in red, I'm going to highlight. So this is where we started, and we also rotate it 2 times. We rotate it 2 times. So if we want to go back to our calculator for a second and just simply change this to a 3, then it's going to be the exact same thing. We're going to start. Let's graph it. It's going to start here, right? And then we're going to go round, and then we're going to do, we're going to keep going 1 more time. So you guys can see that we started here, and that we did another 2. So if we do negative 3, well, where do you guys think it's going to start? And you already know where it's going to start. So we're going to go Y, we're going to go ahead and insert our negative, and we're going to graph this thing, and no surprise, it starts on the other side, right? So it doesn't start at the pole, and yet again, it cycles through 2 times. So we're going to start over here, and then we're going to do 2 times. So what changes with sine? And then we're going to talk about this for a little bit. So let's keep going with this one. I'm so sorry with all the screen, getting all crazy here. So I'm going to go ahead and change this. I'm going to delete this. I'm going to make this going to be 2, and we're going to change this now to sine. So let's pay attention where it starts and how many times it rotates, or how many times it repeats itself. So graph, notice it starts at the pole, and it goes around 1, 2 times. 2 times. So for sine, we start here, and it goes 2 times. Now to save some time, ladies and gentlemen, for 3 sine of theta, it's going to start here at the pole, and it's going to go around 3 times. And then for negative 3 sine of theta, it's going to start here, and then it's going to go around 2 times. So for circles, from circles, a period is going to be pi, right? So we're going to go 1 full time. So we have our period's going to be pi. So think about it like this. Why does cosine start here and sine start here? Well, if you plug in cosine of 0, well, cosine of 0 is 1. So 1 times 2 is 2. So we're going to start our graph at 2. Cosine of 0 is 1 times 3 is 3. Sine of 0 is 0. It's 0. And so then we go and start at the origin. And if you go and plug in, pi over 2, then you're going to get up here to 2, and then pi gets us back down to 0. So same thing with this. If we plug in now pi over 2, we get here. We plug in pi, we get back here to 2. And actually it's negative 2, so it's in the negative direction. It's how we're going to get back to this value. So that's actually important for me to tell you guys that. So that's the circle. So 1 full rotation is pi. All right. And again, where we start is either the x-axis, positive or negative, or the pole for our circles. So here at the bottom, it says, what do you notice about all these graphs? Well, they end up being circles, even though mine look more like ellipses, but that's okay. And how many times does each graph trace on the interval from 0 to 2 pi? And the answer is going to be 2. It's going to be 2. So let's move on to the next group. And so you guys now recognize these from the previous video as limacons. And so what we're going to do is a couple of graphs of this, and then we're going to graph them and see what's going on with these problems. So notice that these are all cosines, these are all sines. What we do understand is that the first number is, so since cosine, we're focusing on the x-axis. Since the major axis is cosine, or the x-axis, the 2 means that we're going to be 2 up, and we're going to be 2 down, right? That's what this means. The sum of these 2 numbers is going to be how far from the pole it is. It's positive, so it's going to be 1, 2, 3, 4. And since the difference of these 2 numbers is actually going to be how far we are on the other side. Also, we know that 2 and 2, they're equal to each other, so we know this is a cardioid, and so it's going to look something like this. It's going to be like a little heart. And again, you guys don't have to go exactly what it is, but it's something to this effect. So here, we know that, again, cosine, so it's 1. So we know that it's going to be here 1, here 1. We know that the pole, from the distance, it's going to be, 3, right? We add these up, 1 and 2, it's going to give us 3. So we know from the pole, 1, 2, 3, again, positive cosine direction. Since we know that the ratio is A to B, right? A over B is 1/2. This is less than 1. We actually will have an inner loop here. So this is an inner loop. And so if we subtract these 2, it's actually going to be right here. It's going to be right here. And so we're going to graph our function. We're going to come through the origin, or the pole, I should say, and something like this. So this is just a really quick review. And again, the second video I did, I explained this more in detail. So this is 2 plus 1 cosine of theta. Well, 2, again, would be 2 here, 2 here. The sum of these numbers, 2 and 1, would be 3. Again, positive cosine, 1, 2, 3. If this had been negative cosine, it would have just been over here. The difference of these 2 numbers would have been 1, right? 2 minus 1 is 1. So this, and then we start connecting our graph. Like so. So that's our examples for this. Let's look at the bottom ones. And we're going to see that, again, they're equal to each other. It's now sine. So 2 here, 2 here. That's for the A part. We add them up. We get 1, 2, 3, 4. And then we subtract them, we get 0. This is a cardioid again. So it looks like a heart in this direction. Here, ladies and gentlemen, again, very similar to this one. It's going to be an inner loop. So we're going to do 3 up. The A tells me this is 1. This is 1. The difference of these 2 numbers is where the inner loop is. And yes, I'm going very fast now with this, because we don't need this particularly to look at this problem. And then 2, 1. So again, we're on the sine. The 2 is going to be here and here. If we add them up, we get 3. That's up here. We subtract them, we get here. And it's going to look something like this. The complex dimple, they're all kind of the same thing. It doesn't really matter. Something like that. So those are our graphs. Awesome, fantastic, wonderful. Two things we have to ask ourselves, and we're going to just look at these two examples right here. Where does it start, and how many times does it rotate over 0 to 2 pi? So let's get our calculator back up again. I think it's turned off on us. That's okay. We'll graph it one more time. So let's go to y equals. We're going to clear this. Now, when you do clear, it's really important that you guys understand that this is automatically going to default back to this. So sometimes you just want to delete it. Let's look at 2 plus 2 cosine of theta, and now let's look and see what happens with this graph. So let's again look, where does it start and how many rotations? So let's graph it. So it starts over here, and then we're going to do a nice little pretty picture, a little heart, and then it stops. Okay, so that's really important that we just come out with this. So the first thing we notice is that we had one rotation, and then it starts right here. Now, ladies and gentlemen, this is the easiest way to understand where it starts. If you don't know, unit circle time. Again, cosine of 0, because this is 0, right? This is pi over 2. Well, in this polar stuff, this is 0. We plug in 0, we're going to get 1. So 2 plus 2 is 4. So we're 4. So theta is 0. The radius is 4. If we go to pi over 2, we plug in pi over 2 here, we're going to get 0. So at pi over 2, we're going to have 2 plus 0, which is going to give us 2. When I plug in pi, so this is going to be the pi over 2 part. When I go to pi, then I'm going to plug in pi. Cosine of pi is -1. -1 times 2 is -2, plus 2 is 0. So this ends up giving us our pi. So that's exactly what we do here. So this is where we're going to start for this problem. This is where we're going to start right here. So again, if I look at this one, the cosine of 0 is 1. 1 plus 2 is 3. The radius from the pole is going to be equal to 3. And that's what you guys can do for these questions right here. This ends up being -1 for pi. And so then 2 minus 1 is going to give you a radius of 1. So even if you don't know what the graphs look like, you can actually just plug in, your quadrantals. So where do you guys think this one's going to start? Right? This is an idea of what we're going to do for this one. So let's get our graphing calculator back out again and start looking at this one. So we're going to go ahead and just do 2 plus 2, and then we're going to go ahead and just change this to sine and graph this thing. Okay, now did that surprise you? Did you guys see where it graphed? Do you see where it started? It started right here, at this point right here. So it started right here. Did that surprise you? And it shouldn't have. This does not start at the pole, because again, if we start plugging in 0 here, we're going to get the 2 times 0, 0, but we still have a radius of 2. We still have a radius of 2. So that's actually what's really interesting. And notice that it started going in this direction. So let's actually look at 5 and see what happens with that one. I'm so sorry. Let's see what happens with 5. And I need to move this little guy around so we can just see it. And then we're going to finish the video up for this one when we're going to summarize these, just so you guys can see it. So this is going to be 1 plus 2 sine of theta. So you guys can see our pretty little inner loop and see where it starts. And let's go ahead and graph this guy. So it starts right here. It follows the circle around, comes up in this way, come back down to right here. So this is where we start. And again, it goes in this direction. So this is where this is going to start. It's going to go in this direction. So the best thing about these, ladies and gentlemen, is that it always starts and it goes in this direction that you see right here. Right? It's going to always kind of go counterclockwise. So what do we notice about these? Well, the question's on the next page. So I'm going to finish this up video with this. So which graphs go through the origins? Which ones do not? Which graphs have an inner loop? How many times does each graph trace? Well, the only most important thing here is that it's only traced one time. Well, how many graphs did go through the origin? Well, and by the origin, we're going to say the pole. We're going to say the pole for this. So we had one that went here, here. We've already talked about the inner loop, right? The inner loop is just going to be the ratio of A over B, and A over B is going to be less than 1, or less than 1, not 0. So that's really the only thing you have to take into account. So that's the idea for this one. I hope that that's making sense. We're going to see you guys in the next video when we start talking about more relationships of our graphs. And I'm going to summarize everything at the very end. So we've talked about circles and the limacons, knowing the graphs, and notice that they were always going to be starting on the positive x-axis.